Modifiability is, I guess, the most underestimated issue in IT. People who are not so much into IT, into software development, for example, they seem to just not realize that this is really an issue, that it costs cost to change a system. Because if you think of IT, it's something abstract, you cannot touch it. So people go along and say, well, just change it. So you can just push the button and then it works. So imagine if you had a house, for example, and you would say, well, could I just please modify the ground floor? Then everybody would say, well, you're crazy, just rebuild it. We'll tear it down and rebuild it. So just business experts who come along and say, well, maybe I want to rerun my business, I want to change my business process. And from tomorrow on, I would not only like to sell, let's say, energy, but I would also like to sell gas and maybe some telecommunication services. So could we please put this all together into one product? And please, dear IT experts, could we then just change the systems? Well, this sometimes happens, and the IT experts would say, well, are you crazy? This just won't work. Because IT is, of course, a large investment. Lots of programmers work underneath to get things going, to build them up, to structure things in one or the other way. And it's very, very difficult if you don't have modifiable systems to change things. So it's not so easy to push that button to make something work in another way than it does now.
Yeah, modifiability is something that should be hidden. You don't see it or anymore. Consider, for instance, Google's search engine. For a user perspective, that has never changed. However, behind the screen, Google is constantly changing the software, improving its algorithms, updating the database with new ways of searching, and so on. And that's the way things should go in the future. That, let's say, what we now have in upgrading from one operating system to the next operating system, from one database to the other, from one application to the other, that is causing a lot of interruption and annoyance. You need to be downward compatible and include or export all your data from one application and import it in the other. That's pretty annoying. It should be dealt with. And that's new technology that needs to be developed, and that's also related to say moving from on-premise software to online software or software as a service. So once you have on-premise software, so it's installed at a customer, then you need to go to the customer and upgrade it and do all the modifications. Whereas when it's online, you approach it through a browser, the vendor of the application can easily modify it without interfering with your operational process. And that will be the way to go for the future.
With the reliability requirements we have, namely that the systems always have to work, the easiest way to solve that is that you don't change the systems. However, in the competitive market that we are active in, we have literally to do upgrades of our systems, if not every week, at least a couple of times a month. And that is the balancing act to ensure that you have the quality, even if you are exposed to a high frequency of upgrades of your systems, and balance the risk versus being exposed to a bug, etc. And that balance is probably the most difficult thing to ensure that you have full control over. Because if we don't upgrade our systems, competitors might step in and take business away from us. So for us to ensure that we are in the forefront and maintain competitive, we have to upgrade our systems.
What computer specialists think about is basically how can we modify systems in a quick way? So how can we code our systems that the usual programmer might be able to do that? And people now tend to invent new ideas like, for example, not programming with code, but programming models where models are much more crisp and much easier to handle. So things like model-driven development are issues for modifiability of systems. And we have to think of many more issues of how to really be able to cope with this. This is what makes programming an engineering discipline, that you have to structure your systems, that you have to somehow presume what will happen in the future, what will be changed, what will not be changed, to be able to do this. What also happens is that many old systems who have been large investments in the past, for example, think of the year 2000 problems, where we had to touch systems that were decades old, that were somehow programmed in the 70s or 80s, and we then had to go back to these systems and see, well, what do we now with them to really cope with this year 2000 problem? That was a huge investment to get them over the border, to make them work in 2001. So, and this usually happens to systems you let alone for a longer time. They age, and it's very heavy or a difficult task to maintain them then afterwards. So this is a real problem.